Hi, in today's video, we're moving on to chapter 2, which is all about geometry. So what we're working on today is what we call a parallelogram. To start us off, let's define what that is. A parallelogram is a quadrilateral with two pairs of parallel sides. So with that information, let's jump to our question. Our question says, in every quadrilateral, there is a hidden parallelogram. You can find it by joining the midpoints of the four sides. For example, in the diagram below, if you join the midpoints P, Q, RS of the sides of quadrilateral ABCD, then you will obtain a parallelogram. Can you explain why this always happens regardless of which quadrilateral ABCD you start with? Okay, so first we are going to draw a line from point A to point C. And now that we have that line drawn, if you guys notice, we now have two triangles. We have triangle ABC and triangle ATC. Let's look at triangle ABC first. Now we have a theorem called the midline theorem. And this theorem says that in any triangle, if two certain points can become the midline of a triangle, then that midline is going to be parallel to the base of the triangle and it will also be half of its length. So now in our triangle ABC, we can see that point P and Q created a midline for triangle ABC. So then the midline theorem suggests that PQ is parallel to AC and that PQ is also half the length of AC. On the other hand, let's look at our triangle ADC. So from our triangle ADC, point S and R created a midline. And again, because of the midline theorem, this suggests that SR is parallel to AC and that SR is also half the length of AC. So from what we found, we can actually see that PQ is parallel to SR and that PQ is also congruent to SR. And when we have a pair of sides that are both parallel and congruent, this means that it is a parallelogram. So then it proves that PQRS is a parallelogram.